Hi, welcome. Now I'm going to show you how to solve TSP in Excel. Okay. What is TSP? TSP is Traveling Salesman Problem. What is that? Probably you already known what is TSP, but I give you just an example. Okay, a salesman is traveling from a city, and he is going to different households in a different city and coming back to his original city. Okay, so while traveling he may be going to 5 cities or 5 places or 10 places. We call it a different city for simplicity. Okay, he is going to 10 cities and he is distributing the things there. Okay, so what is the you can go in different permutations to these 10 cities. You can start from his city. You will go to the city 10 first, give the thing there, then go back to city 5, give the thing there. So it is a lot of permutations possible. You can go and reach all the 10 cities and coming back to his original city. Okay, his hometown. So our problem here is to identify what is the shortest route possible to cover all the 10 cities. Okay, it could be the shortest route possible, or it could be the uh, minimum expense, or it could be the shortest route. Of course, shortest route is the one will give you the minimum expense of the fuel you use for your bike or your van or whatever. And also uh, also the shortest expense, or shortest route possible, or the shortest way time. But if you go keep on traveling, your time may be lengthened. But if you go in a shortest route, automatically it is the lesser time. Okay, this is the problem. It's very well known problem in operational research. Okay, in optimization problems. Okay, this is the problem. What I have is the 4 city for the simplicity, and I also give you a different video for 10 cities. Okay, for in this example, to keep it simpler, I put a 4 city. This is the example 1. Okay, later I will also upload one more video which will have 10 cities and how to solve it. Okay, so for the 4 cities you will understand how to do it, then you will replicate the same thing for any number of cities, for n cities. Okay, this is the city 1, city 2, city 3 and city 4. Obviously the transportation problems like this will have the distance between each city to the other cities. Okay, so this is what our data we have it here. Maybe it may be the kilometers or miles or whatever. Okay, so from city 1 to city 1, obviously 0, so the diagonal you can see is 0. See, city 1 to city 1 is 0, city 2 to city 2 also 0, city 3 to city 3 is 0, city 4 to city 4 is 0. Okay, but you see the city 1 to city 2 is 10 kilometers, city 1 to city 3 is 15 kilometers, and city 1 to city 4 is 20 kilometers. The same thing is repeated as symmetric. It is repeated here in the diagonal. Okay, if you keep the diagonal, you can see the data is symmetric, because city 1 to city 2 is 10 kilometers. Similarly, city 2 to city 1 also 10 kilometers. It's supposed to be the same, so the data always same. For any reason it is not symmetric, then we will handle those sums later. Okay, this is symmetric. Okay, what I'm going to do here is that 3 4 5. Okay, we have the data already. Okay, this is the main data what we want. Okay, by this table what we are going to do is we are going to find out the shortest route possible to cover all the 4 cities. For example, a city may be city 1 and you will go to city 2 3 4 and come back to city 1. Okay, that is the idea. Okay, what we are, so the shortest route, obviously we are going to minimize the distance. Okay, so now what I'm going to do is I'm going to solve this problem using a solver. Okay, this is an Excel solver available for us to solve this kind of LP and linear programming, TSP assignment problems, and non-linear problems. Okay, where can I add a solver? Solver is add-in. Okay, where can I find a solver? You can go to data. You can see here data tools, forecast outline. There is one more group called analyze. Okay, in that you can find solver. Since I don't have it here, what I need to do is I need to add that add-in. How can I add that add-in? I'll go to file, go to options. Okay, it is popped out Excel options. In the options you can see add-ins. In the add-ins you can see solver add-in. Okay, it is available. So what I am going to do is I'm going to add that solver add-in. What I need to do, manage Excel add-ins. Here, manage Excel add-ins, go. It shows you that there are a few add-ins available. The add-in which I need it is solver add-in. Okay, and okay. Okay, now it shows that analyze group where the solver is there. Okay, just fine. We set it up solver successfully. Now what I need to do is we need to define the objective function and the constraints, and then we will go to the solver. Okay, what we are going to do is we need to know these cities. Okay, city 1, city 2, city 3 and city 4. Okay, this is the cities 1. Okay, what I'll put city. Okay, for a starting point I put it is city 1, city 2, city 3 and city 4. Then we will find out, the solver will solve the problem with its own order. Okay, for the starting point our seed is 1 2 3 4. City 1, city 2, city 3 and city 4. Okay, this is our city. This is the order. These are the cells or the variables. Okay, so I want to know the 4 cities in some order. Okay, then I also want to find out the distance. Okay, what is our objective? Our objective is to minimize the distance. Okay, so this is our variables. It will keep changing the values according to the permutation combinations. Maybe he is going for a city 2 first, city 3 first, then 4, then 1. It can be anything. It will keep changing. These 4 cells will keep change. According to that, I need the distance. Okay, what is the distance? I need the distance from this array. Okay, for this array, to make it easier and simpler, what I will do, I will name the array first. Okay, I'll say select the distance table. I'll select the distance table and go here, define name. I'll give city distance. So for this data set, I just name it city distance. Otherwise I need to every time select the range. Okay, I don't want to do that. I just put a city distance, the name. Okay, what is the distance here? Okay, in the first city, okay, in the city 2, city 1, then it goes to city 2, then city 3, then city 4, finally it comes back to the city 1 itself. So always the first city is supposed to be the distance from the last city. If you are not known this logic now, just keep for a while. I will come back to the first city later. First we will go to the second city. The second city is nothing but the distance is traveling from the first city to the second city. Okay, so the distance between the first and the previous city and the current city, okay, which is index. So index value will give the respective value from this matrix. Okay, this matrix, which is nothing but this array B22, this array, which is nothing but a city distance. We already named the array to city distance. Okay, this city distance, comma, what is the row number? The distance between two cities. Which two cities? The previous city and the current city. Previous city is 1 G2 and the current city is this one. Enter. Okay, is it true for the city 2? Yes, previous city is 1 and 2, the distance is 10. 2 and 1, the distance is 10, both are same. Similarly, equal to index city distance, comma, city 2 and 3 distance, previous, comma, the current. You can see 35, 3 and 2, 35. Then this one, index array is nothing but a city distance, comma, 3, comma, 4. Okay, now I find these three distance. Okay, what is the first city's distance? Finally is going back to his first place, so it has to be from the last city and the first city. Now I think you can understand. So this gives a circular form of cities. Okay, so this circular form also helps you can start from any city, whichever city the salesman is currently available, his hometown is. Okay, so this is a circular form. Okay, anyway, I'll give index of array is city distance, comma, distance between the first city and the last city, or for your understanding, from the last city to first city, both are same. Okay, is it first and last city is 20. 20. And now you understand that it not necessarily first city is city 1, it could be city 2, then city 1, then 3, 4, any order. Okay, for a seed purpose we are giving in the first starting solution, we are giving 1, 2, 3, 4. It may not be the right solution, but it is the initial solution. We are providing it to the solver. Okay, and the solver is going to find all this city order. Okay, city order, and this is the point where the objective function comes. We are going to minimize the sum of the distance. We are going to, this is the any order, it will bring you a distance. So what is the total distance? This sum of, this is the distance. Enter. This is the overall distance. Okay, this is the overall distance. Maybe I put, this is the overall distance. Total distance. Okay, now understand, this is the objective. Our objective function is this, to minimize this distance, and our variables are this city order. Okay, we already given the data. Based on this data matrix, we already finding the distance, so we no need to worry about this data. It's already feed into the distance automatically. When the solver trying to solve this, automatically it brings the data here, because we use this array or the city distance naming data set, okay, here to calculate the distance. When the solver tries to do this order 2, 3 and 2, automatically this data is bringing from here. So we are not doing anything, we are not touching here, we are going to touch only here. Okay, now we will go to solver, data analyze solver. Objective cell must be a single cell on the active sheet. Okay, objective cell. Okay, now I delete first. Okay, this one, delete this one. Okay, now you can see this solver window. You can see non-linear, simplex, LP and evolutionary. Okay, evolutionary is the one we are going to use it for TSP. Okay, you can find it here why we are using, what is the reason. GRG non-linear engine for solver problems that are smooth non-linear problems. LP is linear engine for linear solver problems. Select the evolutionary engine for solver problems that are non-smooth. Okay, this is the evolutionary solving method we are going to use. Okay, what is our objective? To set objective is on the distance, only one cell, and what we are going to do is we are going to minimize. Okay, what is our changing variable cells, which is nothing but this set, city order. These are the cells, keep changing in this order, we want to change it. Okay, what is our objective? For this kind of TSP problem, our constraints are simple. That is our constraints, this city order, add the constraints, What is the constraints? Constraints nothing but a city order or different, because otherwise it will simply put 11111, because the city 11111 is all 0, the distance is 0. Okay, we want different cities to be considered here, so all are different. So select, there is one option here, diff, it will give you all different. Okay, add that constraint, you have all different. I repeat again, the objective function is the minimizing the overall distance, minimize. The changing values are the city order values, and our constraint is very simple. The city order values supposed to be all different. Make unconstrained variables non-negative, it is non-negative, and our method is evolutionary method. Okay, now we are going to solve it. I just click solve. What will happen? Let's see. Yes, done. It already solved the problem, and you can see it also gives you some reports. Okay, you can also, you want population and answer in reports, you can select the reports and give outline reports, return to solver parameter box, or just close. Okay, now you see it has given a order here 1 3 4 2. Okay, 10. So this is the order the salesman has to go. He has to go to, start from the city 1 if he is in city 1, go to 3, then 4, then 2, again go back to 1. This way he will get only distance of 80 kilometers. This is the shortest distance possible in the given distances of these 4 cities. Okay, for example, he is in city 4 currently. Okay, since it is circular, I told you already, remember, he is in city 4, then he can go to city 2, then to 1 3, then go back to 4. His hometown is in 4, he is starting from his office in 4, is currently 4, city 4, then he has to move on to city 2, then go to 1, then 3, then go back to 4. Okay, this is the way. Or if he is in 3 4 2 1, then go back to 3. Okay, this is the way. Or in the it not necessarily clockwise, it can be in anti-clockwise also, but the shortest distance is 80 kilometers. Okay, this TSP is solved. We will see what is there in the reports. See, the original value what we are given, final value is 80. For our original initial solution given 95, final value is 80. Answer report and population report, cell value, what is the mean value, standard deviation about the population, all this. Okay, you can see city order. What is the order now? Currently is 1 2 3 4, now it is 1 3 4 2. Okay, so this is the way you can analyze you can see the reports of the solution, and the actual value is here. You can see it is solved, and the value is 80, and the city order is 1342. Hope this video is helpful to you for the TSP, but for the fun purpose, you see, if the TSP is not used, how much the salesman will travel according to this distances. What is the possibility of maximum travel? We can use that fun in the solver itself. Same problem, I'll use it maximum. I am just maximize the same problem. You see, 95. So you can go for maximum of 95 kilometers. But if you use the TSP, you can gain 15 kilometers. If you go use the TSP, you can gain 15 kilometers. For this problem, only 4 cities, it is 15 kilometers gain. But if it is 10 cities and all, you will get hundreds of kilometers gain. Okay, hope this video is helpful to you. This way you can start using solver as well as working on TSP problems. And also, if I try to upload one more video on 10 cities, and as well as the other simplex method and other things also. Okay, hope you like this video. If you like, you can like my videos and subscribe to my videos, my channel. Have a good day.